Good morning, everybody. We've already heard today about the theme of our day, GIS Uniting Our World, and Peter's articulated to us some of the challenges that we're facing in our world today as a society, and really some of the uncertainties that we're living with. And we've seen some amazing work that's going on to tackle some of that, but I still think some of these things can be quite sobering. But what brings us together today is a shared desire to make change in our world, coupled with a conviction that geography offers us a compelling way to do that, a compelling way to understand our world, to understand the systems of our world and how they interact and how they relate to one another. And it offers us ways to model different futures so that we can choose which one it is we're going to create. So as I look forward, I'm excited because of this partnership that we share together. You know, at Esri, we are committed to building world-leading technology that puts geography at the heart of decision-making, but then we get to put that into the hands of smart people. And actually, you here today, you're a really important, a really special set of people because you're dedicating your work and your lives to making change in our world through these approaches. So what I'd like to do this morning is share some of what we're doing here, how we're building ArcGIS to support your work. And I want to talk about three things. First, let me tell you about some of the work that we're doing with AI. Now, ArcGIS is a services-based platform. So what that means is that if I want to view a map or perhaps geocode this building that we're in or maybe perform some spatial analysis, all of those capabilities are wrapped up and they're stored centrally within ArcGIS. And they're accessed by apps that make requests and get responses of information. And all of ArcGIS works like this, right? So whether I'm doing mapping or whether I'm doing geocoding or spatial analysis or routing or any capability, it's all centrally embedded in the system and then accessed over this services framework with requests and responses. So one tool set that we have is our GeoAI framework. And we've had this framework in ArcGIS for many, many years. It's where we take AI approaches to solve geospatial problems. So today we use approaches from the fields of computer vision and machine learning and others to really supercharge our geospatial analysis, to solve problems faster and more efficiently. And that's to do things like object detection and feature extraction, and you might be familiar with some of that work. But recently, we've also been focused on building out a second set of AI tools. And that's really based on generative AI and natural language processing. Now, you might have come across these techniques. They underpin some tools you're probably familiar with, things like ChatGPT, Microsoft Copilot, Google Gemini, and a variety of others. So what we're doing is we're using these underlying AI techniques to build out a comprehensive set of AI skills to do things like more intelligent semantic search, to offer you things like mapping assistance, code generators, app generators. These skills are tightly coupled with ArcGIS and specifically trained and optimized to work with our tools. Now, when we build apps, they get hydrated with all of these capabilities across this services framework. So if we want to take advantage of AI skills, at Esri, what we've been doing is building out these AI assistants in our apps that allow us to ask questions in natural language. So between you and me, that just means normal words, right? Like the words I'm speaking now. That's what natural language is. And so, of course, what this is about is making GIS more accessible, making it easier for people to ask those complicated questions. So let's take an early version, for example, of our arcade assistant. Coding can be complex, but if I can ask the assistant a question in natural language, normal words, then that assistant can go off and generate me arcade code to specifically solve that problem. Now, of course, I could ask any generative AI tool to go and generate me some arcade. The difference here is our assistant has been specifically designed to work with arcade across the whole of the ArcGIS platform. It's been specifically trained and optimized on that tool set, and then it's been embedded across the different apps and workflows of ArcGIS so that you get a consistent experience no matter where you access it from. So as we continue to build out these AI skills, what you'll see in the apps is these skills come through into the productive apps that you continue to use, and you'll see those capabilities start to get leveraged at that level. And obviously, developers can build out custom skills and custom apps as well. Now, one area that I think is really, really important as we start to put AI into ArcGIS is this area of trust and ethics. And many of us are acutely aware already of the responsibilities that we have around the ethical use of location data about the privacy aspects of dealing with location, particularly where people are involved. And at Esri, as we started to put AI into ArcGIS, we've really looked at this as an extension of those responsibilities. And you can find out all of this information on the ArcGIS Trust Center. You'll find a set of guiding principles which we have adopted at Esri as we have done this work. We talk about the security and the privacy and the transparency with which we have put AI into ArcGIS. We talk about how we handle your data, the fact that it's your data and not ours. We don't use it to train AI models unless you explicitly choose to do so. We don't take any ownership over your data. We don't expose it outside of the Esri system. You'll find a set of safeguards. For example, we have chosen to make generative AI tools inside ArcGIS an opt-in framework. So what that means is you can go away and do your due diligence on all of this before choosing to switch it on. And you'll also find we talk about AI as a shared responsibility. So this means that there are things that you need to take care of and your organization needs to take care of to assure the ethical use of AI in your ArcGIS systems, and we give you some guidance around that as well. So I think this whole area of trust and ethics in AI is vital, not only for the security, the privacy, the protection of intellectual property, or what I would call these hygiene factors of digital life, but actually because if people don't trust AI, they won't use it. And then we as a society, we won't benefit from all of the things that it has to offer us. Now, let's switch focus a little bit. We recognize that ArcGIS is a comprehensive, capable platform in its own right, but that also many of you rely on it to be integrated with other business workflows in your day-to-day work. And for that reason, we've actively designed ArcGIS as a system that is open and interoperable. Now, some of this is about standards, of course. So ArcGIS supports a variety of standards across various paradigms, not only those from OGC, but also things like IT standards, like OAuth and SAML for managing identity and security, and a variety of others. But open is about more than standards. And some of it is about what I've just been speaking about. It's that we've actively designed ArcGIS as a services-based system to ask those questions and get those responses. That means that you can do that from a variety of different ways. It means we've developed and published and productized and documented a set of APIs. These are just technical ways that you can ask questions and get responses. We've actually productized a whole set of software development kits around those APIs. They're also fully documented. We actually use those SDKs to build Esri apps and Esri products. They're available to you to use as well. We've also integrated ArcGIS directly with a variety of other business systems that you can see on the screen there, like from Microsoft, Autodesk, SAP, lots of others. These enable collaborative bidirectional workflows. And one of the latest integrations that we've been working on is with Microsoft Fabric. This is Microsoft's new enterprise analytics platform, and we have partnered with Microsoft to spatially enable this platform. And what we've done is we've put ArcGIS Geoanalytics natively within Microsoft Fabric so that Fabric users can get access to spatial tools and approaches. So once again, this is about expanding access to geographic approaches. And if we can help put these tools and techniques that we're all familiar with into the hands of people who otherwise wouldn't come into contact with them, we can start to shape and offer these spatial approaches to a much wider variety of people, paradigms, approaches, and different work, as Pete has been talking about this morning. And really, part of this is, Microsoft have got a huge ecosystem. They have over 1 billion users in their whole ecosystem. If we can expose spatial approaches to those people, just think about the impact that we can collectively have in this community. Now, strong integration is also central to something else that geography is at the heart of, and that is in building and operating digital twins of our world. And Pete has touched on this a little bit already. But a digital twin is essentially a model of a real-world environment that we can configure and ask questions of and run simulations and interrogate, and then use the outcomes to make better decisions in the real world. And geography is really at the heart of this area for 2 reasons. The first reason is GIS, or the science of geography, it offers us ways to manage a variety of different environments and to model a variety of different environments. So we can model natural environments, like environmental systems and weather systems, ecology, river flows. But in equal measure, we can model man-made systems. We can model buildings and construction and transport systems and retail and insurance. So we've got this opportunity to model different types of systems. And then the second reason is that geography is perfectly suited to bridge these systems together. So if I have data that is in two completely different data sets that is entirely unrelated from each other, and I want to understand how they're connected, I can use geography and I can use the location of those assets and those entities to start to bring insight, to start to connect these systems, to start to understand the relationships and how these things link together. So geography works as an index. And that combination is really powerful, that ability to model a variety of systems and then bridge them together. So just think for a moment. You in this room and your organizations, you are the custodians of the data sets that make up a digital twin of the whole of the United Kingdom. And therefore, if we're going to unite our world and solve some of these major challenges that we've been speaking about, you are a pretty important set of people to collaborate with and also between each other. And at Esri, part of our work is in building the tools and the approaches that allow you to do that. So, rich imagery capabilities and 3D fused together with reality mapping to create these immersive experiences. A whole suite of spatial analysis tools that allow us to ask these questions, to model these different situations, to interrogate systems, run simulations. Real-time data flows, connecting all these systems together, bringing connectivity, insight, allowing us to make those decisions on the fly, and really enabling these living digital twins. So this partnership that we have is really, really important. Not only with us at Esri, with you, but also that you share with one another as we try and look to solve some of these problems in our world, as we unite our world and we look to shape and protect our future. So what I'd like to do now is look in a little bit more detail at some of these capabilities that I've just mentioned. And in order to do that, I'd like to invite to the stage Lauren McArtney. Lauren is a senior product manager here at Esri UK. She looks after Suite for ArcGIS, so please give Lauren a warm welcome.
Wonderful. Thank you very much, Mark, and thank you to everyone here today. So, I'm going to be kicking off with something that I'm quite passionate about. Now, I first came into Esri UK a couple of years ago, and I landed in our ArcGIS localization team, who actually handled the curation of the Living Atlas. This absolute treasure trove of ready-to-use, authoritative content that I feel truly lays the foundation for a lot of the products and the capabilities that we're going to be highlighting this morning. Now, it's also key to a lot of the themes that Mark just spoke about. So collaboration, interoperability, building digital twins through geography. Now, the Living Atlas is comprised of thousands of data sets. You have environmental data, like here we're looking at WWT's wetlands for carbon storage and flood resilience layers. You've got transport data, like the Strategic Road Network of England from National Highways. You've got weather data, like the predictive and historic climate data from the Met Office. In this case, we're looking at the number of summer days across the UK. So really, this is built from a lot of the work that you are doing, and that we're doing too. With our ever-expanding base map collection, we've got new accessible styles in there as well, or our precipitation forecast layers that we've created and we've contributed in there for you to be able to use. But it is more than just data. You've got ready-to-use web maps. You've got tailored web applications, pre-trained machine learning models, and live data feeds as well.
Yeah, and we're committed to building this repository of information, but we need your help. And by contributing information into the Living Atlas, you're enabling other organizations to make better decisions using your authoritative data. And to help with that, we have recently launched something else, a premium content store.
Yeah, so this is quite exciting. What we've done here is we've partnered with Skywatch to design an intuitive platform for accessing and for purchasing premium imagery. Now, this imagery, it's searchable, it's downloadable, and it's directly accessible within ArcGIS. Now, at its baseline, the content store allows you to acquire imagery in a more frictionless way, but it also provides our partners with a new platform to be able to list their premium content. Now, whether you're using some of this premium imagery or you've found an incredible data set from within the Living Atlas, It's really when these are coupled with your own data do you start that journey towards creating really beautiful and really compelling maps. Because it's through mapping that we can express and we can understand geography and the world around us. It's the cartographic choices that we make that allow us to tell the right story to the right audience.
Right, and ArcGIS gives us a powerful set of tools to articulate these stories in creative ways. And we have instant apps and story maps and dashboards and app builders. And you can find out more about all of these things here today. And as we tell those stories, we map the location of objects and where things are. And we start to look at the patterns and the interactions between objects and how one relates to another. And that really takes us into the area of spatial analysis and data science, which is about uncovering patterns and extracting knowledge using geography.
Right, you can access spatial analysis across the ArcGIS system, whether you're using ArcGIS Pro or whether you're leveraging WebGIS with ArcGIS Online and ArcGIS Enterprise. Now it also includes the exciting field of geo-AI that Mark was talking about earlier. So that's taking your traditional AI approaches like computer vision, machine learning, and deep learning. And on top of this, we also have tools to address the spatial analysis of big data. So for example, ArcGIS Geoanalytics Engine, where you can take this analytical power and you can point it at your own Spark data stores.
Yeah, and these are the tools that I was talking about earlier that we've recently embedded inside Microsoft Fabric so that Fabric users can access them directly as well. Now, we've also brought spatial analysis to graph databases. So knowledge graphs map how entities are connected, and they help us to explore the relationships between them. And ArcGIS Knowledge brings the power of spatial graph analytics to these approaches as well.
Now, in ArcGIS Online, something new is that we've released Model Builder into the map viewer. And this is currently in beta right now. Now, previous to this, the only way that you could access this type of functionality was through desktop GIS, so ArcGIS Pro. So what this allows you to do is string together various analysis tools. You can create multi-step workflows, you can share them, and you can execute them all within ArcGIS Online now.
So this tells you a little bit about some of the areas of focus that we have at Esri. Last year, we released ArcGIS data pipelines. This year, we're releasing Model Builder on the web. We're increasingly wrapping up these professional GIS capabilities, and we're bringing them into WebGIS because it reflects how you are increasingly working. And it also provides choice for you to be able to access these approaches through a variety of different ways, on the web, on the desktop, or through mobile, whichever workflow is most appropriate to your work.
Right, so we've just talked about ArcGIS as a comprehensive system for spatial analysis. And the same is true for 3D. So 3D is supported across the ArcGIS system, from analysis to visualization. It also powers workflows like 3D editing and immersive experiences through support for game engine technology.
Yeah, and 3D is one of these foundational capabilities that underpins digital twins that we've already spoken a bit about today.
Yeah, and one of the areas we're seeing really grow is in the modeling of indoor environments. Now, these maps here, they're not just about navigation, as important as it is. They are about enhancing safety. They're about improving visitor experiences or just optimizing the spaces that we have. Now, Mark, imagine having detailed, interactive indoor maps of our airports, our hospitals, our schools, our own office buildings. They're connected, they're readily available, and they're driving really important decisions. Now, this is an area that Manchester University Foundation Trust is actively exploring right now. So to tell you a bit more about what they're doing, I'm going to hand it across to Amy.
Thanks, Lauren and Mark. Today, I'm going to share with you how ArcGIS is supporting space management and the planning of services for the public. The NHS has long been a cornerstone of our society, providing essential healthcare services to millions of people across the UK. It's a service that we all use and turn to in times of need. However, in recent years, the system has been under increasing strain. In the news, we see issues such as ward closures, long wait times, and staffing challenges, along with newer problems like RAC, deeming some buildings unsafe and affecting the space that can be used for our health facilities. We have worked together with the Estates and Facilities team at Manchester University NHS Foundation Trust to showcase how ArcGIS is helping them to optimize the placement of services within a hospital setting and alleviate some of these challenges. I'm excited to share the amazing work going on behind the scenes to keep facilities running and improve patient experience. I'll first share how MFT are using ArcGIS to understand their indoor space, and then we will look at how we can use this data combined with community demographics to make decisions that optimize health services. This is a representative example of the data that MFT have for their hospital site. ArcGIS Indoors has allowed this to become a living model that drives different workflows. Let's take a look inside the hospital. We can see a detailed map of the interior, and we can start to interact with this data to get a better understanding of the space within. A key thing about this application is that the model is floor aware. I can use the floor filter in Experience Builder to move through each level and see just the rooms on each floor. I also have a list of services within the hospital, and so I can use this to filter the type of facility, which team is occupying which space, and also the condition of this. If I select treatment rooms, we'll now see just these rooms on the first floor of the hospital, and we can see which team is using which treatment room. I can also see how these link up with the corridors and stairwells, so we know how accessible they are to patients and staff. For MFT, this application is a single source of truth. If a ward moves or a space is repurposed, all staff can access this information in one place. For maintenance teams, they would previously have had to request the site data from the estates team, and then go and find out who occupies that space before they could arrange to do any work. However, CAD files of the hospital would quickly become out of date. The indoor model by the estates team has solved this and has created a collaborative data environment for all teams within the hospital. Now all a maintenance team member needs to do is come to this application, select which rooms are in need of repair. They can then identify which team they'll need to contact to arrange this and what that repair will be. So I've just shown how this functions as a communication tool, allowing teams within the hospital to work more efficiently. Clinicians can also use this to plan space. Take this empty unit, for example. This could be repurposed for a number of things. It could be a new maternity unit, a pediatric ward, potentially more office space. Clinicians can look at the facilities for each service currently and make an informed decision on how this vacant space could best reflect the demand for services in this community. The provision of health services isn't just within the walls of this hospital. Health facilities can be and are being more placed within the community. These are in the form of community diagnostic centres and neighbourhood hubs. MFT have recognised the importance of understanding the location of all their facilities, how they serve the communities they operate in, and how this improves patient experience. And this is no different for their midwifery services. I mentioned earlier how we would use the indoor data combined with community demographics to make decisions that optimize health services. I'll now explore how we can use ArcGIS Pro, demographic and transport data to find the optimal place for midwifery services across Manchester. We'll understand whether that vacant space we just saw within the indoor application would be best repurposed for this, or whether a community clinic would be better. I'm going to use ArcGIS Pro so that I can use spatial analysis tools with demographic data and network analysis tools with transport data. I've loaded in the data that MFT already has, which includes the location of the community hospital over here that we just saw from the indoor application, and also community clinic locations. I'm going to pull in some data from the Living Atlas, which, as Lauren mentioned, is a curated library of content. The data I'll use is female population estimates from the ONS, which is available for all of you to go and use as well. This is available in 5-year age brackets, and so I've amalgamated a selection of these. Let's take a look at the data as it is. I've got two layers, one for the ONS estimate for 2012 and another for 2020. With the data as it is, I can pick out the darker areas where there would be a higher demand for midwifery services. However, I can also use spatial analysis tools to identify clusters and help me understand changes between the 2 years. I'm going to use, and bear with me here as this is a bit of a mouthful, the hotspot analysis comparison tool from the Spatial Statistics Toolbox. This tool takes two hotspot layers and tells us in what way they differ. Before I can run this, I need a hotspot layer for 2012 and one for 2020, which I've already created using the hotspot analysis tool. Let's take a look at the 2020 layer. You can see that hot and cold clusters have been identified. Areas with a higher demographic for women, or hot areas, are in red, and cold are in blue. These two layers are the input to my analysis tool, and I'll keep the rest of the parameters as default. Once I've run this, two layers are added to the map, the first showing similarity and the second showing the significance of any difference. The bold red areas here and the lighter red areas here are key to my analysis. If you look at the legend, you can see that the bold red is a category called not significant to hot. This is identifying where there was not a significant demographic for women in 2012, but in 2020 there was. Hot to hot is identifying areas which between the 2 years always had a high demand for midwifery services. I'll come back to these areas shortly. I'm now going to look at some transport data because I want to make sure that any midwifery service will be accessible to both patients and staff. The data I'll use for this is open data published by Transport for Greater Manchester of public transport stops, routes, trips, and schedule information. At the moment, you can see that this is just points, and if I was to try selecting each point to see how frequently a bus comes by it, and then align this with the facilities and demographic data, I think my patience might quickly dwindle. I'm going to use the Public Transit Toolbox in ArcGIS Pro, which allows me to calculate the frequency of scheduled services. The input for this will be that data from Transport for Greater Manchester, which is a generic transit feed specification, or GTFS for short. This format of data is widely available for most of the country. I've run this already, so we'll take a look at the output now, which is a layer showing how often a bus service uses a stop. Darker spots have the highest number of buses departing per hour. What I've then done is just taken the stops with a bus service departing 10 or more times per hour, so I know which locations are most accessible. So let's recap what I've just done. We've now got a far better understanding of which locations are most accessible using open data, and also understood which areas have the highest demand for midwifery services using data from the Living Atlas. What I've then done is using an intersect, identified where these things come together, and an area that is a prime location for a midwifery service. If we think about how we started this process, planning indoor space in the hospital, and also looking at community clinic locations, we can see that that free space we saw before that was available at the hospital over here wouldn't necessarily serve the community most effectively, and that actually one of these clinics or another leased area within this space would do so better. This isn't to say that other areas won't benefit from a midwifery service. It's that this analysis has helped us understand where the highest demand is. For a clinician planning space, this is incredible insight and helps ensure that spaces within the hospital and the community are as effective as they could be. The analysis I've just completed isn't a standalone workflow either. To run this in one go, I've used Model Builder, which is a visual geoprocessing canvas for building repeatable workflows. All of the icons you can see are the data and tools I've already talked about, but pulled together into one place and linked using a flowing diagram. What's really useful about this is the data sets can be switched out, and in this way, the model can be used for other regions, other cities, or other services. This can also be packaged up and shared with others so that colleagues can use the same tools and workflows in ArcGIS Pro. So I've just said that the model can be used for other services, and so let's have a think about what that really means. Many of the NHS facilities we have available to us are great examples of services which could benefit from this kind of analysis, as it's possible for them to be located in a neighbourhood hub instead of a hospital site. These include screening locations, blood donor centres, addiction rehabilitation services, and surgical hubs. And as I said, all of this isn't a standalone workflow. As Mark and Lauren mentioned earlier, if you're using ArcGIS Online, you can also now use Model Builder in the web. I can create an analysis workflow and share that with my entire organization, or a specific group of people that might benefit from seeing how I did that, or might want to run it themselves. Here, I've created a version of the model that we saw in ArcGIS Pro. I've then switched the demographic data to look at current blood donation services and where there are hot and cold spots for these. We can see that the area around the hospital over here is lacking for this service and would potentially be a good location for this facility. So we can come back to the space management application and update this. We're back to that vacant space we saw earlier, and through the workflows I've performed in ArcGIS Pro and through Model Builder in ArcGIS Online, we now know that the community demand aligns with a blood donation centre rather than a midwifery service. Once this room has been repurposed, we can use the edit widget to come and update this. This will mean that the connected data environment for MFT is up to date and that all hospital teams will be aware of this change. I'll turn back on the rest of the room so we can see how this has become part of our clinical space. We can also see that fortunately it's right next to a food preparation area, which is perfect as all people will want after giving blood is a cup of tea and a biscuit. The management of space by MFT and using demographic and transport data to inform this highlights the power of data-driven decision-making. I think we can all agree that the work being done by MFT is transformative, and that this approach not only enhances operational efficiency, but also ensures that the needs of our community are being met and ultimately improves patient experience. I'll hand back to Mark and Lauren.
I mean, Amy, that was excellent, wasn't it? It's just really, really important work. And you've just taken us on a tour as well of a variety of different capabilities in ArcGIS to support this. You know, looking at indoor mapping, using 3D and spatial analysis techniques, working in ArcGIS Pro and ArcGIS Online, and using a variety of applications that have been specifically tailored to support that different type of work. So thank you very much. In fact, you know, all of those things that you saw Amy doing are accessible through her ArcGIS user type.
Now, at Esri, we offer access to various capabilities through 6 user types. Now, about 12 months ago, we simplified access to ArcGIS by moving away from licensing individual products to enabling you as users. Now, each of the roles that you can see on screen here provides you access to a set of capabilities through specific apps designed for different types of work.
Yeah, so we have our foundational apps like ArcGIS Enterprise, ArcGIS Online, ArcGIS Pro, but today, not every GIS professional needs to use Pro. And we have many, many people, lots of you here today, in fact, I'm sure, using ArcGIS Online and WebGIS to perform your work. And we're continuing to focus in that area at Esri because putting more capabilities into that space allows you to build these powerful yet simple to use, you know, workflow-driven point-and-click style applications, which really allow you to design different capabilities for different types of work, which makes these approaches more accessible to more and more people.
And over the next few weeks, we'll be adding even more apps and more capabilities to these user types, so you have that to look forward to. Now, you may not have realized it right away, but a key part of the journey that Amy just took us on was about data management. For MFT, aligning their data from a spatial perspective was that vital hook that allowed them to realize their vision within ArcGIS indoors. And that's what data management is about. It's about modeling really specific environments down to an incredibly fine level of detail and then repeating that across multiple scenarios. So whether that is through foundational geodatabase management or it's through editing workflows, now more tightly integrated with WebGIS via the new ArcGIS web editor, it's really through effective data management that we can create really powerful and really accurate digital twins of our world. Moving now to field operations. And I'm going to take a guess that there are quite a few people in the room that rely on field operations. Now, these are your mobile workers. And this here, it's about data collection. It's about being able to update and edit data in the field for greater situational awareness. And we have some really powerful applications to support you in doing this. One of them is very appropriately named Field Maps. And this is our comprehensive solution for online and offline workflows at scale. We then have Survey 123, which is more focused on your form-centric data capture. And then we have Quick Capture, which is about capturing sets of observations quickly.
So at Esri, we are focused on building a comprehensive portfolio of purpose-driven applications that are really transforming field workflows, and we're going to continue to do that. Now, ArcGIS is a complete system for managing imagery, and this is really an area that we've seen exploding over the last few years with access to remote sensing techniques increasingly accessible to all of us. And ArcGIS allows us to manage all types and formats of imagery at very high volumes, including drone, aerial, and satellite. And we've also designed specific tools for map and data production in our reality mapping space. This is supporting organizations that are building those information products that really fuel the GIS and the digital twin communities.
Yeah, and ArcGIS allows us to put these information products to use with tools to analyze, to visualize, and to share across the system. Looking now at real-time visualization and analytics. So this is about the tracking, the monitoring, and the alerting of continuously changing data. Now, it's the real-time capabilities within ArcGIS that allow us to connect digital twins and turn these models into living systems. Systems that can learn, they can respond, and increasingly they're providing insight, and they're making decisions more autonomously. So now, let's take a closer look at how the real-time capabilities and the imagery capabilities within ArcGIS, enhanced by GeoAI, are helping to maintain one of our major road networks. So I'm going to hand it across to James.
Thanks, Lauren. I know I'm guilty of taking our roads for granted. I don't always when there's a pothole in front of me or when there's a slowdown on the M40. But despite my frustrations, our roads are critical to keeping us growing and connected, whether that's to reach loved ones, to travel to work or school, or to deliver goods across our country. We rely upon our roads every single day. And because of this, there's a monumental amount of work to keep our roads open and running safely. And at the heart of this is the strategic road network managed by National Highways. This complex interchange of A roads and motorways across England, alongside those in Scotland and Wales, forms the backbone of our country's transport network. And what you're looking on screen is what Lauren described earlier, the public network model of the strategic road network. And you can see it's quite expansive, covering most of the country. In reality, that's 4,500 miles of motorways and highways that take on 95 billion vehicle miles each year. To put that in context, that's 1/3 of all vehicle miles and 2/3 of all heavy goods vehicle miles that are driven. And that takes place on just 2% of our country's road surface. But it's not just a road surface that National Highways look after. It's 25,000 structures, including pipes, bridges, and tunnels. It's 30,000 hectares of land, some of which are used for biodiversity net gain, others for habitat restoration. And because of this complexity, it requires 39 million hours of people's time each year to maintain, improve, and renew our road network. So now if we look back at that same video of a road we may have taken for granted, we start to see things we didn't see previously. Maybe it's the lighting fixtures on either side of the road, the retaining walls, the road markings and cat's eyes, or the soft estate, so the grassy verge and trees on either side of the motorway. All of this needs to be maintained and managed. If you're an expert geoguesser, you may have realized that this is in fact the M25. And that's where Connect Plus services enter the story. A joint venture between Balfour Beatty, Atkins Realis, and Aegis, Connect Plus services operate and maintain the M25 on behalf of National Highways. And because of that complexity that I spoke about earlier, They have unique project teams who look after the different parts of the motorway. They have an environment team who are concerned with protected and invasive species, a network operations team who are concerned with the current state of the network at any given moment, bringing in those real-time feeds that Lauren described earlier, like CCTV footage or the live traffic feed from the Living Atlas. They also have a maintenance team who are in charge of road markings, debris, and litter across the motorway, and a structures team who look after all of those pipes, bridges, and tunnels that I mentioned earlier. Now, the challenge is, with these 4 different teams, you have 4 different ways of working, 4 different ways of managing data, and even maybe 4 different ways of mapping the exact same space. But what Connect Plus services have done is they've united these teams together into a single view of the M25 using ArcGIS. Now, if you're driving home tonight, don't worry, this is not a live view of the network. But what it does show is how you can see where all of the work is happening at once and see all of the project team's data together. So let's say I'm a project manager on the environment team, and I'm doing some work around junction 6 of the M25. I can zoom into that area and understand it better because the project teams have shared their data. I can see what the network operations team understand about the space, alongside my own data from the environment team, and then I can also check to see if the road maintenance team are doing any work within that existing area. Now, it's powerful that I can visualize this all together in one space. With ArcGIS Experience Builder, we can implement business workflows. So one of the keys for Connect Plus services is to make the most of every closure on the road. We don't want to close it tonight and then find out we're doing work in the same area, close it again a week later. So using a simple spatial query, I can check to see if any of my environment tasks line up with closures that already exist across the motorway. And in this case, it looks like there's a lane closure that might be perfect. It's been created by the road maintenance team, and it's coming up later this week. Now, using a survey in ArcGIS Survey 123, I can take that information, pass it into the survey, and notify that project manager that my environment team is going to be doing some vegetation cutting work during those dates. If I go ahead and submit this, it'll notify that project manager, and then they can approve my work onto that existing closure. Now, this is key because we're being more efficient. We're adding more work into the exact same closure. And in that spirit of efficiency, what we at Esri UK have been doing, we've been working alongside Connect Plus services to leverage imagery and AI to help create more efficiencies and do some digital inspection work before we go out to the motorway itself. Let's take a look at what that looks like. So here we see the exact same road corridor, but now visualized as a 3D point cloud. So millions of accurate points that give us not only a rich visualization of the motorway itself, but all of those structures and the vegetation that line it. And this could be accessible to anybody from Connect Plus services who log in to ArcGIS Online and look at it. Now, it's cool that I can actually interrogate this data. So if I wanted to make a measurement, let's say from this tree to the edge of the shoulder itself, I could see the distance from that vegetation to the hard shoulder, and I can make a determination about whether we should be doing vegetation cutting work in this area. Now, that's quite powerful, but you imagine if I were to do that for every single tree alongside the M25, that'd be quite a monumental task. But what we can do using machine learning tools is classify what is the road, what are structures, and what's vegetation. And that helps us build up something like a 3D road corridor, but also a buffered road corridor, which gives us our recommended 5-meter distance. But then now that we have these two corridors, what we can then do is isolate specifically those trees that intersect and are too close to the motorway. So if I turn those on, you can see all of those point clouds being highlighted using some 3D spatial analysis. And what this allows me to do is create a new task sitting here from behind my desk. So I can check that this tree will need cut. I can make a task at that point. I can give it a vegetation cutting, and I can assign it to the environment team with a priority and a date that aligns with that closure we identified previously. So now we've created a task, and that can be accessible not only through ArcGIS Online in a browser, but also through mobile applications out in the field. But we can also go one step further. As part of the work that Connect Plus services do, they have rich aerial imagery that allows us to identify road markings, but in particular, we want to look at where are the faded road markings. Using AI tools, we can not only extract where those road markings are, but we can classify them using that natural language model that Mark mentioned previously. So in this case, if I input those road markings from the imagery, and I bring in a deep learning package, I can ask in natural language to find me either faded or not faded road markings. I can also pull in some additional context to help tell the tool what I'm looking for. In this case, it's looking at some aerial imagery, find the white road markings on the black tarmac. Perhaps most importantly, though, we can bring in a connection file where we can point this model at one of the large language models that exist in the web, like OpenAI's model. And this allows us to, in blue, identify where all of those faded road markings are. Now, of course, no model will be in itself perfect, but we can publish up those results to ArcGIS Online to validate and create new tasks. So in this case, let's look at one of the white arrows that the model identified. Here, if we zoom into it, it's found it out as a white arrow, it said it's faded, and luckily for me, it's given it a 100% confidence score. From this view, I can say that yes, this definitely does need repainting, and we can then, just as we did previously, create a task from this view, assign it to the maintenance team, give it a priority. Now, this is powerful because I was able to make these two identifications from behind a desk. I didn't need to close down the motorway or send out a worker next to a busy intersection to identify that this work needed to be done. But of course, I can't fix any of those problems standing behind a desk. Only somebody out in the field can. However, we can leverage the same logic of collaborating across teams, bringing together each other's data to help work more efficiently and safely out in the field. So imagine we have the mobile worker and their environment tasks. We can supplement their understanding using data from the ecology surveys, the utilities team, as well as the location of nearby teams and their workers. But perhaps most importantly, we can alert these workers to hazardous areas out in the field using a tool called geofences. So if there's an exposed cable, or there's protected or invasive species, we want to alert workers to those locations while they're doing their work. Let's see what it looks like from the mobile workers' view. So here we see they have access to the exact same data, but now in ArcGIS field maps on their phone. As they navigate towards that exposed cable, they'll get a banner notification that says, hey, look out, there's an exposed telco cable, it's purple, navigate away from that so that you can work safely. Now, as they go towards their task itself, they can see some information about what it is they need to do. In this case, it's a vegetation cutting task. They need to move it back 5 meters. But perhaps more importantly, we can ask an additional question. By knowing that this is an ash tree, we can just ask the worker to identify whether there are signs of ash dieback. In this case, it looks like there might be lesions on the tree. They click yes, and then they'll say, work completed is partial. And then they'll give a reason why, in this case saying there might be tree disease or damage spreading in the area. Now when they submit this task, what they're doing is not just updating the project manager on the status of their own task, but also alerting arborists to the fact that disease might be spreading in the area. And this is important because it not only keeps everybody in the loop, but it makes our single view of the M25 up to date. And if we think about what the other story could be, it could be those 4 teams operating in silos, not collaborating, not sharing data, creating an avalanche of inefficiencies. What Connect Plus services have done is chosen the other story. They've collaborated across teams to allow them to work more efficiently and safely, keeping our roads open for longer and keeping our country connected and growing into the future. So with that, I will hand back to Mark and Lauren.
Thank you, James. An incredible story there of the power of geography. Building and operating a living digital twin, integrating 3D, fieldwork, real-time, and AI. So thank you very much for that.